We will now explore various properties of logarithms that will allow us to evaluate expressions and to solve equations. Many of these are not new. Many of these we may have observed in previous sections when we've been evaluating logarithms, so don't look at this as a big long list of rules to memorize. Many of them are just observations that will help you to evaluate more quickly and to solve equations. The first property, it says the log base a of 1. So an example would be log base 7 of 1. So you may remember this is asking for the power of 7 that will give us a 1, or 7 to what power would give us a 1. So we remember the only power we can raise on any base that will give us a 1 is 0. So this really isn't a new property. We already have observed this. We're just stating it here more formally. The second one, log base a of a. So for example, log base 7 of 7. This is asking for the power of 7 that would give us a 7, or 7 to what power would give us 7. So we know this would give us a 1. So our observation is when the base is the same as the argument, we're going to get a 1. So log base a of a is 1. Natural log of e, remember the base of a natural log is e. So this is really log base e of e. So that's the same rule. Base and argument are the same, so the power of e that would give us e would be a 1. Now let's skip the third one here for a second and come back to it. Let's look at the next one here. Log base a of a to the r power. So here's an example. Log base 7 of 7 squared. So this is asking for 7 to what power would give us 7 squared, or what power of 7 would give us 7 squared. So we know that would be a 2. So the observation here is when the base of the log is the same as the base of the argument, your answer will be the exponent of that argument. So more generally, log base a of a to the r power is just r. And then with a natural log example here, natural log of e squared, so that's like log base e of e squared. So again, the base of the logarithm is the same as the base in the argument, so we're just going to get that 2. Okay, we'll come back to this third one here. This one is a little more obscure, it's a little less intuitive, and honestly it's not as common. You may see a few questions like this in the homework, maybe one on a quiz or a test, but don't spend a whole lot of time sweating over this one. Just practice it a little in the homework and give it some time to sink in. Okay, so let's go right to the example. This is saying 7 to the log base 7 of m. So this is raising 7 to the exponent log base 7 of m. Remember, logs are exponents. A logarithm is an exponent. So if we go up to this exponent, log base 7 of m, this is saying the power of 7 that would give us m. So what power, 7 to what power would give us m? Well, now I'm raising a base of 7 to this power, so then we're just going to result in m. So the observation is if the base of the exponent is equal here again to the base of the logarithm, we're going to end up with the argument. So over here with the e to the natural log, so remember that's e to the log base e of m. So again, the bases are the same, so this is saying e raised to the power of the power of e that gives you m. So you're just going to get m. So over here, generally, a to the log base a of m is just m. So again, just practice that a little bit. It's a little less intuitive, but it should click after a little bit of practice, but that won't come up a whole lot. It won't come up as often as the other properties here. Okay, so let's look at the next one. Log base a of mn. So what we want to look at here is log base a of a product of m and n. So here's an example, log base 9 of 35. So I'm going to rewrite 35 as 7 times 5. So when I take the log of a product, I can split that up into log of each of those factors and add. So you can split up log of a product into the sum of the two separate logarithms. So back here to the general rule, log base A of mn. So when you take log of a product, you can split that into the sum of the two separate logarithms. So then conversely, if we look at log of a quotient, log base 9 of 3 halves, 3 divided by 2, I can split this into log base 9 of 3. Ooh, whoops. Log base 9 of 3. Don't do that. Log base 9 of 3 minus log base 9 of 2. So when you take log of a quotient, you split it into the difference of the two logs. So over here, generally, log base A of m over n is just the difference, log base A of m minus log base A of n. Okay, the next one, again, this is not necessarily a new rule. You guys may have observed this already. But here it's when we take log base A of the argument m to the exponent r. So here's an example, log base 7 of 11 squared. We can take this exponent of 2, bring it out into the front, and multiply. So log base 7 of 11 squared is equal to 2 times log base 7 of 11. So this rule allows us to bring the exponent out into the front and multiply. And again, this will be useful when we solve equations. Sometimes this will allow us to more easily solve an equation. So over here, generally, we can bring this r out into the front. So we'll have r times log base A of m. Okay. The next one here, this should be very intuitive. This is saying if I have an equation, m equals n, it's basically saying I'm allowed to take log of both sides. Just like when we balance an equation, we're allowed to add something to both sides of an equation, multiply to both sides of an equation, take square root of both sides. This is basically just saying we can take the log of any base, as long as we do the same base to both sides. We'll have, oh, whoops, that should be an n. You'll have an equivalent statement. So it's basically saying you're allowed to take log of both sides. And vice versa, if you have two logarithms equal with the same base, then you can say that the arguments are equal. So this is like the same rule going both ways here. And then finally, the change of base formula. This is useful because you may recall that our calculator can only do two bases, base 10 and base e. So if we want to evaluate or if we want to graph functions, logarithmic functions with bases that are different than 10 or e, we can use this change of base formula to change the base into either e or base 10, or any base, but e and 10 are the useful ones for graphing and using our calculator. So the change of base formula, I'll just show you the example first. If we have log base 7 of 5, this is equivalent to changing it to whatever base we want. So we'll use base 10, common log. Remember when we don't put the base on there, we assume it's base 10, common logarithm. So we can convert this into the quotient of log 5 and log 7. Again, we can pick any base. We could also choose, for calculator purposes, we could choose natural log. So the rule is basically log of the argument over log of the base. So over here, generally, we can change this into log any base, I'll call it b, of that argument m over that same base b, log base b of a.